All right, today's lesson uses congruent triangles to prove corresponding parts are congruent. We have a little phrase that discusses corresponding parts are congruent. Do you remember what that phrase is, or acronym? Yep, and we're going to be using that a lot today. CP, Can one person raise their hand and tell me what those stand for? All right, go. So corresponding parts, there's that word, corresponding parts of congruent triangles are congruent. There it is. So we're going to be using that a lot today. So we can use that to prove that triangles are congruent, and we can also kind of backtrack and say, well, if the triangles are congruent, then all their parts are congruent. So that's how we're going to use it today. So we are trying to prove parts now. We're trying to prove parts are congruent. So at the end, our reason, guaranteed, is going to be that CPCTC. Anytime you're proving parts, you're going to be saying that acronym. So sometimes, though, we have to add some reasons, add our given marks, make sure they're noted properly to prove that these parts are congruent. So 1 and 2, do they have marks on the picture? Nope, we have to add them. Those are my givens. What about A, B, and D, E? Are they marked? No, so we have to add those as well. Definitely don't have enough information at the moment. We need more. Yes, we have vertical angles. So if you add the marks, you have to state the reason. Vertical angles. Now do we have enough? Oh, doubles? Yeah, I need doubles because I already have singles. There's actually a little bit more that we could do. Deals with angles, that's my hint. Deals with angles. Ooh, yeah, I just heard it. Somebody said they saw a linear pair. So, down here in this region, there's a linear pair, and the same thing goes for this one. There's a linear pair right there, and that's back from chapter 1. So the key thing you need to see is that angle 1 plus, how do I name this angle right here beside it? Angle ABC it can't be B in that case because it has a 1 beside it. They are 180. I could do the same thing for this other intersection down here. And once again, I can do that because they're a linear pair, and a linear pair is supplementary. All right, the next thing, we can do this similar stuff over here on this other intersection. See if you can lead me through it. What would I write? Angle 2 plus, okay, so you can name it two different ways, either DEC or CED, and I'm fine with either one. They add to 180 for the same reason. They're linear pairs, so they're supplementary. These two have something in common. What do they have in common over here? They both equal 180. If they both equal 180, then I can set these pieces equal to each other. So that's what I'm going to write now. Angle 1 plus ABC equals angle 2 plus CED. Why can I do that? Who remembers that reason? Okay, transitive mostly we use for congruence. It could work. There's one that I like a little bit better. Substitution. Good. I heard it from somebody back there. Substitution right there. I could spell substitution. So that was substitution. Where this one equals 180 and that one equals 180, I can just substitute in. Next up, I know something about these pieces in here. What do you all remember about these pieces? Do we know the angle measurements on ABC and CED? Do we know that? Nope, we don't know them yet. Do we know something about 1 and 2 related to each other? Oh, over here we were given that they are equal. So if they're equal, that means I could substitute one for another. But truthfully though, think about this. If this was your math equation. 3 plus x equals y plus 3. If you had this on both sides, how would you get rid of this one? You would subtract it, right? And when you subtract it, they both cancel. So if you have the same thing written on each side, what's going to happen to them? Okay, so same operations, they're going to cancel. So you could get rid of those with what math property? What math property? Subtraction would get rid of those two. So ABC is equal to CED because of subtraction. Yes, and that was a lot of work for that little part. Now, since they are the same, they are congruent, what can I do on the picture? Mark it. So I already have single, double, now I'm on triples. Yes, a lot of work to prove that. So this section starts the beginning of doing a little bit more, pulling in more past information. Now I think everybody sees it. Why would those triangles be the same now? Okay, so I could say the triangles are the same. So how do you want to name this lower one down here? How do we want to name it? DCE. Now let's make the other one match. It's congruent to what other triangle? What matches with D? A. A, B, C. They are congruent for what reason? I think you see the marks on the triangles. AAS. Good. Now, I told you the last step before we even started. I said to prove parts are congruent, what are we going to state? All right, so that's the last thing you need to say. DC is congruent to AC because corresponding parts, congruent triangles, are always congruent. So when you're trying to prove parts at the end, you're always going to give that final reason with it. If you're just trying to prove the triangles are congruent, you could have stopped right here and that would have been fine. All right, for example 2, it's talking about boats. It says use the following method to find the distance between the two docked boats. It helps out by telling you where to place marks, so then they're going to end up over here. And you can do that quickly on your own. We're going to save a little time and just focus on the picture now. So the key thing, we are trying to figure out which distance. We're trying to figure out the distance from point A to point B. So please pay attention on where I place marks. This is the unknown distance right here that we're trying to get a mark on that spot. If you saw these pictures right here, we have a shortcut where we can place a mark somewhere. Where can we place a mark? Vertical angles, automatically right here. You place the mark, you write the reason. Get that in your head. Place the mark, you write the reason. Now, look at the marks we have so far. A lot of that should come back. Yeah, I hear it. What? Now, some people are saying HL. All because it's a right triangle doesn't mean it's HL. What does H stand for? We don't have a hypotenuse mark, so it's not HL. All right. This one is angle, side, angle. The side is between the angles. Angle, side, angle proves what? Okay, so I'm going to shorthand that. It proves the triangles are congruent. So I'm going to say the triangle is congruent to the other triangle. Yay. But am I trying to prove the whole triangles are congruent, or am I trying to prove parts are congruent? Yeah, I'm trying to prove this part right here. So how do I prove that AB is congruent to what other piece? Let's make it match. ED. AB. So it starts out at this vertex that's pointed, then goes to the 90-degree angle. So AB matches with D. ED. And yeah, I've already heard it, CPCTC. I'm not too concerned about this real life portion of it right now. I don't think it's super practical. You probably won't end up doing that in real life. I am focused on being able to do this, and this is definitely doable on the tests and quizzes. Try out checkpoint 1. I'm going to give you a little bit of time. These are overlapping figures. That's my hint. These are overlapping figures. So you're going to have to figure out which triangles to focus on. So be careful. All right, here we go. Now this one takes a little bit of thinking. You got to think out of the box. We haven't done these with overlapping triangles before. So the first thing is you got to pick out triangles to focus on. And I saw a lot of people kind of focusing on these over here. And people noticed something about those two angles. What do we notice? Yeah, so a lot of you got that. And then kind of got stuck a little bit. I think that's pretty helpful though right now. Yeah. Oh, you're going to say another step? Okay, go ahead. Okay, so you're saying this piece is equal to itself. Which two triangles would you be focused on then if you're going to talk about that? PSR doesn't even touch PQ, so that wouldn't help a whole lot. It wouldn't help a whole lot. Let's pause for a second. Let's pause for a second and figure out what we're trying to prove. PR and QS. So PR is this long piece down through here. I'll make it blue. I'm trying to prove that piece and this piece. So really, let's focus on one of them. If you just focus on this, you can obviously see a triangle over here and then a triangle over here. And I'm going to give you a hint. We're going to focus on this one over here. We're going to focus on this PSR right over here. Currently, we have this piece marked. We have that angle, which doesn't really help us though. But you should see that you have another triangle over here that's really similar to it. And I'll draw that one as well. QRS. And ultimately, we're trying to figure out these pieces. We're trying to link those together. This is all we really have on those two triangles right now. So now I'm hearing the correct reflexive one. So when these two triangles here are placed on top of each other, they share the SR piece. They share this piece right here. They both have SR, and you can see it in the pictures that I drew. So we now have an angle and a side on each of them. We need a little bit more. So I gave one person this hint. I said, focus on this triangle down here. This little triangle should look familiar. If you see a triangle that looks like that, what would you tell me about that triangle? That's an isosceles triangle. And what should you remember about isosceles triangles? Two sides are the same and two angles are the same. Which two angles are the same? In this picture right here, which two angles would be the same? The bottom left and bottom right, S and R. So that's these down here. So I already have single, double, I need triple. Now, how can I mark those angles on my new pictures, or can I? So PRS, is that over here? Can I note that one? No, can I note it here? PRS, definitely. This one over here is QSR. I don't have it here, it's over here, QSR. Now, the reasons for doing that were definition of base angles. You haven't seen that a whole lot. That's definitely on our list of reasons though, and you can see it over there. That's definition of base angles. We had vertical angles. What did we put these marks on for? I didn't write the reason, I'm sorry. That was reflexive. So far we have reflexive. Draw the mark, write the reason. Perfect. Good little mantra to repeat. Now, you should be able to say something about these two triangles. AAS. These two triangles are congruent. I'm shorthanding it because of AAS. What does that allow you to say? Yeah, it allows you to say parts are congruent. Which parts are we trying to prove congruent? QS is congruent to PR. And we know that short, quick reason is CTC. Yes, it is difficult to put all these ideas together, especially when they're overlapping. So I definitely recommend separating out some triangles. Picking the correct triangles, though, is one of the most challenging things, so be careful there. We're going to practice more of these, so don't stress out if you're not getting it yet. On example 3, it says, write a plan for the proof. So that's kind of what we've been doing. We haven't been doing like super formal proofs. We just mark the triangles, write the reasons out. So that's what we're going to be doing on this as well. But you got to pick the correct pieces. So I'm going to just focus on that picture, and I'm going to focus on what we're trying to prove. So just focus on this stuff. Do not focus on the rest. Right now we're trying to prove these two triangles are congruent. So let's find them. ABD and then ACD. These two triangles right here are the ones I'm trying to prove are congruent. So those are the ones you need to really focus on. Immediately on those two green triangles, you should see somewhere to place a mark. Yeah, awesome. Place a mark, write the reason. Good thing to be able to do really quickly. Now, if you just saw those only, you'd be stuck there. You're out of reasons. However, I kind of hinted at something we hadn't done a whole lot, and it dealt with a special type of triangle. We had to use base angles. Isosceles, do you see an isosceles somewhere in that picture? BDC. I think everybody sees it. Everybody sees that BDC down at the bottom. What's marked on it so far? These base angles. Well, if the base angles are congruent, then you can say the two sides are congruent. What's the reason, though? Can y'all see a reason over there? So I'd say it's between definition of isosceles triangle or definition of a base angles. So we'll just be focused on the base angles right now. So we'll repeat that one again. That's because the base angles are congruent, the legs opposite them will be congruent. So I can place those marks, and those would be doubles. Now focus on those two green triangles. Do we have enough information? Okay, so the triangles are congruent because SAS, so you can see side, angle, side. And are we done? Yeah, we don't need CP/CTC because we're not proving parts. So we're done there. Try out this checkpoint. You got to pick out the correct triangles. It tells you which ones to focus on. You got to be able to tell where to add reasons. This one is different. All right, so this next one is pretty tricky. Has a lot of interesting aspects to it, though, and some stuff that you haven't used in a while. So this is going to bring back some old stuff. First off, let's focus on the triangles we're trying to prove. F, J, K. So that's over here. Right now, it doesn't have a lot of information. The other one's over here. So these two green triangles are the ones we're eventually trying to prove are congruent. Right now, they're not touching each other, so we can't exactly put the kind of marks we're used to for our shortcuts. Let's see if these givens are marked. G, H, K, J, are they marked? Yep. F, G, L, K, definitely marked, so that's good. And we have our right angles marked as well. So that's always good to check. Make sure the givens are marked. That way you can get the easy ones knocked out of the way. After that, we got to really focus in on these two triangles. So let's focus on this one first. Is there something we can add on that one? Okay. You could prove that this is a right angle. So the question is, why can we prove that's a right angle? And there's a few different ways to do it. Okay, so it links in with supplementary angles. I would take that. I would also take linear pair. If you say one of those two, I can tell you're on the right track. You're doing well. Oh, if you can say it for here, where could you also say it? The other one. So that's a good realization. Now, we have a side mark and an angle mark. We definitely need more, though. Yes. Yeah, so it links to this one, and this one links to this one. So it really doesn't help a whole lot. You're right. So we're probably not going to do that one. Did anybody get anything different? Add anything more? Okay, so here's where some people get stuck. I agree. This is a sticking point right here. So I'm going to highlight something that you probably haven't seen in a while. This piece right down through here, G to K, GK. I can break that up into a lot of different segments. I could say JK, JH, HG, and I'm going to do that real quick for some specific reasons.